Hello students, this is Ingrain. Welcome to the channel and welcome to the new video. Today we will continue the chemical changes and reactions. In this chapter, you are expected to learn the concept of chemical change and chemical reaction, characteristics of chemical reaction, types of chemical reactions, energy changes in a chemical change, and factors affecting the rate of chemical change. Out of which we have already covered the concept of chemical change and chemical reaction and characteristics of chemical reaction in our last episode. For all the new viewers, you are requested to watch the last episode from the link given in the description box. In today's episode, we will cover the types of chemical reactions. In our last episode, we have already come to know that there are four major types of chemical reactions. The first one is direct combination reaction or synthesis reaction, where a single product is formed. The second one is decomposition reaction, where two or more simpler products are formed. The third type is displacement reaction or substitution reaction, where one element replaces another element. And the fourth type is double decomposition reaction, where complete exchange of radicals takes place. In this episode, we will learn each of these types in great detail. So the first one is direct combination reaction or synthesis reaction, which is represented by A plus B gives AB. Let's take some examples to understand this clearly. When carbon reacts with oxygen, it forms carbon dioxide. When phosphorus reacts with oxygen, it forms phosphorus pentoxide. When calcium oxide reacts with water, it forms calcium hydroxide. And when zinc reacts with oxygen, it forms zinc oxide. In all this type of reactions, you can see that two reactants reacts to give a single product in all these cases. So we can say when the molecules of two or more substances combine to form molecules of a single substance, the reaction is called a combination or synthesis reaction. The second type is decomposition reaction, which is represented by AB decomposes to give A plus B. Let's take some examples. When mercuric oxide is heated, it forms mercury plus oxygen. When zinc carbonate is heated, it forms zinc oxide and carbon dioxide. Whereas when calcium hydroxide is heated, it forms calcium oxide and water. And potassium nitrate, when heated, it forms potassium nitrite and oxygen. So here you can see that a single compound is decomposed to give two simple products. So we can say when the molecules of one substance split into two or more simpler substances, the reaction is called decomposition reaction. Also, you must remember that this decomposition reactions takes place in presence of some external agents. As in this reactions, you have seen the external agent is heat. So this decomposition reactions are called thermal decomposition reactions. The other decomposition reactions are photochemical decomposition, which occurs in presence of light. For example, silver chloride in the presence of light decomposes to silver and chlorine, and silver nitrate in presence of light decomposes to silver, nitrogen dioxide and oxygen. So you can see how in presence of light silver salts are decomposed, and this is the reason why silver salts are kept in colored bottles to prevent it from the decomposition by sunlight. The next type of decomposition is electrolytic decomposition, which occurs in the presence of electricity. For example, water in presence of electric current decomposes to give hydrogen and oxygen, and molten sodium chloride in presence of electric current gives sodium and half Cl2. This type of reactions are commonly observed in electrolysis, which we will study in some other chapter. So students, don't forget to subscribe the channel and click the bell icon to get all the latest updates. The third type is displacement reaction or substitution reaction, which is represented by A plus BC gives AC plus B. You can see how A is replacing B from the compound BC. This happens on the position of elements in electrochemical series, which is a series in which the elements are arranged in terms of their reactivity. The most reactive elements are at the top and the least reactive elements are at the bottom. The more electropositive metal displaces a less electropositive metal. Same goes for the non-metals. Let's understand this with some examples. Iron Fe plus copper sulfate gives ferrous sulfate plus copper. Now locate the position of these elements in the electrochemical series. Iron is over here, which is above copper. So iron can replace copper and it can form FeSO4. Similarly, the next example, chlorine plus KBr gives KCl plus Br2. Now chlorine is located here before bromine. So chlorine can displace bromine. Magnesium plus zinc chloride gives MgCl2 plus zinc. That means here you can see magnesium is located before zinc in the electrochemical series. That means magnesium can replace zinc. Similarly, zinc here is located above hydrogen and hence it can replace hydrogen from HCl forming ZnCl2 and hydrogen. So we can say when an element displaces another element from a compound and takes its place, the reaction is called a displacement or substitution reaction. Now how will you remember this electrochemical series? Now there is a trick which you can use for your reference. You can see this is the electrochemical series where the elements are denoted by their symbols. Now to remember this, you can simply learn this statement. King Narendra caught Maggie, allow Zinat Ferreira, lead Hugo with a chain of mercuric, silver, platinum, gold. Now K here is for potassium. So remember K for king. Na, sodium, that is Narendra. Ca for calcium, it is caught. Like this, all the symbols are represented in this statement. So if you remember this statement, you can easily remember the entire electrochemical series, which will help you to answer your questions. The next is double decomposition reaction, which is represented by A plus B minus plus C plus D minus gives A plus D minus plus C plus B minus. Let's take some examples to understand this. Calcium chloride plus sodium carbonate gives sodium chloride and calcium carbonate. So here calcium is going with carbonate and sodium is going with chlorine. So there is a complete exchange of radicals. Similarly, when ZnNO3 whole 2 plus Na2CO3 reacts, they form NaNO3 plus ZnCO3. Here also you can observe zinc is going with carbonate and sodium is going with nitrate. Hence there is complete exchange of radicals. Similarly, PbNO3 whole 2 plus 2NaCl will give NaNO3 plus PbCl2 and ZnSO4 plus NH4 whole 2 CO3 gives NH4 whole 2 SO4 plus ZnCO3. So you can see zinc is going with carbonate and ammonium ion is going with sulfate, forming ammonium sulfate. So we can say when the molecules of two compounds exchange their radicals, to form two different compounds, the reaction is called a double decomposition reaction. Now you can see in all the reactions there is an insoluble precipitate forming. CaCO3, ZnCO3, PbCl2 and ZnCO3. So this type of reactions are also called precipitation reactions. Therefore, we can say reactions between two compounds in aqueous solution state to give two new compounds, one of which is insoluble, is called precipitation reaction. Also, precipitation reaction finds a great use in analytical chemistry for identifying the positive radicals in salts by analyzing the color of the PPT. So if you have an unknown salt and if you want to know the positive radical in it, then from the color of the precipitate you can get to know that. For example, if you have an unknown salt, for example FeSO4, which is unknown to you, and if you treat it with sodium hydroxide, you will get a dirty green PPT. From this green PPT you can understand that the positive radical in the salt is iron. Let's take another example. When copper sulfate reacts with sodium hydroxide, it forms sodium sulfate and copper hydroxide, which is a pale blue PPT. Now from the color of the precipitate, you can identify that the positive radical is copper. Another type of reaction is neutralization reaction. The reaction between an acid and base to form salt and water is called neutralization reaction. Let's take some examples to understand this. When HCl reacts with NaOH, it forms NaCl plus H2O. That means an acid reacting with a base gives a salt and water. Also, you can see that there is an exchange of radicals. Hydrogen is going with OH forming water and sodium is going with Cl forming sodium chloride, which is a salt. So this is also an example of double decomposition reaction. Let's take another example. When sulfuric acid reacts with copper hydroxide, it forms copper sulfate and water. Also, when nitric acid reacts with lead hydroxide, it forms lead nitrate and water. Moreover, when nitric acid reacts with lead oxide, it forms lead nitrate and water. In all this type of reaction, you can see that an acid is reacting with a base, be it a soluble base or insoluble base, it forms salt and water. Also, neutralization reaction is a double decomposition reaction. Don't forget that. The reactions are called neutralization reactions because the products formed as a result of these reactions between acids and bases are neutral to litmus. This neutralization reactions has a lot of applications in our daily life. For example, the toothpastes are alkaline, which neutralizes the acids secreted by bacteria. The acidic soil is neutralized by using calcium hydroxide, which is a base. Moreover, sometimes the amount of HCl in stomach increases, which is called acidity. The milk of magnesia, which is an antacid, is taken to neutralize the acidity. So you can understand in case of indigestion, when you take an antacid, it is basically an acid and base reaction. Ant sting contains formic acid, and to nullify the effect, moist baking soda is used, which is a base. So these are some common applications of neutralization reactions in our daily life. Hoping that today's elementals are embedded, we encourage you to take up the self-check assessment. This segment is specially designed to test your understanding of today's lesson. Give a balanced equation for a direct combination reaction that involves two elements, one of which is a neutral gas and the other monovalent metal. So you have to give a balanced equation where a neutral gas and a monovalent metal is involved and it's giving a direct combination reaction. Next is define and represent displacement reaction. Give a reason why zinc displaces hydrogen from dilute sulfuric acid but copper does not. What happens when iron 3 chloride reacts with sodium hydroxide? Identify the type of reaction. And the last question is, give 2 applications of neutralization reaction. The solutions of the self-check assessment will be discussed once we complete the entire chapter. You may give your feedback in the comment section and let us know which portion of the video you like the most. Also, if you have any doubts or queries, you may post that as well in the comment section. Do watch our previous episodes from the links given in the description box. Meet you in the next video with a new episode. Till then, take care and study hard.